Hello, my fabulous fifth graders. Today's lesson is on adding unlike fractions. Our I can statement today is I can use equivalent fractions to add and subtract unlike fractions. Before we get started, let's remember what we did last week. Last week, we added and subtracted like fractions. So here's an example. Delmar ran 5/6 of a mile on Wednesday and 1/6 of a mile on Friday. How much farther did he run on Wednesday? I can tell that this is going to be a subtraction problem. I have 5/6. I'm going to subtract 1/6. And since I have like denominators, I know I can simply subtract the numerators. 5 minus 1 is 4. 4/6 is my answer. But when I look here in my answer choices, I don't see 4/6 listed. That's a clue to me that the answer that I found, while it's correct, might not be in its simplest form. Let's simplify it. I know that both 4 and 6 are even numbers. All even numbers have 2 as a factor. So just real quick, I'm going to divide by my big 1. And I'm going to put 2 over 2 inside my big 1. 4 divided by 2 is 2. 6 divided by 2 is 3. There it is. 2/3 is the simplest form of 4/6. Delmar ran 2/3 more on Wednesday. Last week, we used fraction strips to make models of adding and subtracting like fractions. This week, we're going to see how we can add and subtract unlike fractions. So here's an example. To finish building a birdhouse, Jordan uses 2 boards. One is 1/2 foot long and the other is 1/4 foot long. What is the total length of the boards? The first step is to model each fraction using fraction tiles and place them side by side. So here's our model. We have a 1/2 fraction model and a 1/4 fraction model. Our next step is to find fraction tiles that will match the length of the combined tiles and line them up below the model. I can use the 1/4 fraction tiles to fill the length of 1/2 and 1/4. There are 3 1/4 fraction tiles in all. This represents the fraction 3/4. So 1/2 plus 1/4 equals 3/4. So the total length of the board is 3/4 of a foot. Let's try another example with fraction tiles. We need to find the sum using fraction tiles. I have 1/2 and 1/6. I know that since they have different denominators, I can't just simply add them. I need to find another way to name them so that I can add them. I want you to know for a fact that the answer is not 2/8. This is a no. So, what is it that we should do? Well, first, we are going to find a 1/2 and a 1/6 fraction tile and lay them down together. Our next step is to find which fraction tile we could use to cover the same distance. And I see now that if I use 1/6 tiles, I can create the equivalent distance. And I have 1, 2, 3, 4. I have 4 1/6 tiles, which is also known as 4/6. 4/6, however, is not in its simplest form. So we are going to have to try and simplify it. To simplify it, we need the greatest common factor. I know that 4 and 6 should have some common factors. Factors of 4 are 1, 2, and 4. Factors of 6 are 1, 2, 3, and 6. The greatest common factor is 2. So I'm going to take 4 sixths, and I'm going to divide it by the big 1. Inside my big 1, I'm going to have my GCF. That's 2 over 2. Now 4 divided by 2 is 2, and 6 divided by 2 is 3. So now we are ready to give our final answer. One half plus 1/6 equals 4/6 or 2/3. So what is the relationship between the least common multiple and adding unlike fractions? Let's think about the example we just used. We had 1/2 and 1/6. We ended up using 1/6 tiles to cover the distance that 1/2 plus 1/6 made. Now we're going to see if we can figure out, well, where did we get 1/6? How did we know which fraction tile to use? The answer is our least common multiple. Let's see. Remember that multiples are many and factors are few. Many fifth graders get the greatest common factor and the least common multiple confused. When we are looking for equivalent fractions to add and subtract unlike denominators, we cannot use the greatest common factor. We have to use the least common multiple. Multiples are the numbers that you say when you skip count by a number. So let's try it out. We are looking for common denominators. So we are going to be finding the multiples of 2 and 6. Multiples of 2, 2, 4, 6, 8, 10. Multiples of 6, 6, 12, 18, 24. Let's see. I can tell that my least common multiple, the least multiple that shows up on both lists is 6. 6 is my least common multiple, and I will need it to add these unlike fractions. Let's try an example. Noah backed up 1/5 of his computer memory. Then he backed up 3/4 of his computer memory. How much of his computer memory has Noah backed up? Let's follow these steps below. First, we need to find the least common denominator. Here's a hint. The least common denominator is the least common multiple. So we're going to find the common multiples of 4 and 5. 4, 5. 4. 4, 8, 12, 16, 20, 5, 10, 15, 20. The least common multiple is 20. The least common multiple of 4 and 5 is 20. So that is the least common denominator of the equivalent fractions. So we want to turn 1/5 into a fraction that has 20 as a denominator. We have to figure out what we do to 1/5 to turn it into an equivalent fraction with 20 as a denominator. Well, what do I do here? What do I do to 5 to make it a 20? I multiply it by 4. So I'm going to multiply by 4 over 4, also known as my big 1. That means, since I multiplied my denominator, I must also multiply my numerator. 4/20 is equivalent to 1/5. Let's try it again over here with 3/4. I know that 20 is my common denominator. That's my goal. Well, what do I do to a 4 to turn it into 20? I simply multiply it by 5. So I'll multiply the numerator by 5, and I get 15. So now I have like fractions. I have 4/20ths and 15/20ths. Now that I have like fractions, I simply add the numerators. 4 plus 15 is 19. My denominator is 20. Noah has backed up 19/20ths of his computer memory. Now that sure is a lot of steps. I've used this graphic organizer here to help keep track of all the steps, make sure that you do them in the correct order. So let's try using this graphic organizer that we will be using in class to solve some problems with unlike denominators. Let's try first adding 1/3 plus 1/4. Now, our first step is to rewrite the fractions as equivalent fractions with common denominators. In order to find the common denominator, we need to find the least common multiple. The least common multiple of 3 and 4. So let's see. 3 and 4. Multiples of 3. 3, 6, 9, 12, 15. Multiples of 4 are 4, 8, 12, 16. My least common multiple is 12. That means that over here, I need to rewrite the fractions as equivalent fractions with 12 as the denominator. So first I'm going to take 1/3. I'm going to make an equivalent fraction with 12 as my denominator. What did I do to this 3 to turn it into 12? Well, I multiplied it by 4. I must also do the same thing at the top. 1 times 4 is 4. Now let's do that with 1/4. I need to turn it into an equivalent fraction with 12 as my denominator. Now I have to think, what did I do to this 4 to turn it into 12? Well, I have to multiply it by 3. That means I must do the same thing up top. 1 times 3 is 3. So I have changed 1/3 plus 1/4 into a new problem where these fractions have a new name. Now I am adding 4/12 plus 3/12. Since I have like fractions now, I have 7/12. Now, here in this step, 7/12, I need to look and think, does this answer need to be converted into a mixed number? Does this fraction represent a quantity greater than 1 whole? No, it does not, because my numerator is smaller than my denominator, so I do not need to convert this to a mixed number. Now, I move here. Do I need to simplify my fraction? Well, I know that 7 is a prime number. The factors of 7 are 1 and 7. Now, 1 is a factor of every number, so that's not going to help me simplify. How about 7? Can I divide 7 into 12? Nope. That tells me that 7/12 is in its simplest form. My answer to 1/3 plus 1/4 is 7/12. Let's try it with a word problem. Angel has 2 chores after school. She rakes leaves for 3/4 of an hour and spends 1/2 hour washing the car. How long does Angel spend on her chores in all? So we have 3/4 of an hour plus 1/2 of an hour. Let's use our graphic organizer to help us. We need to rewrite the fractions as equivalent fractions with common denominators. Well, here are our denominators. We want to make them common using the least common multiple. Let's find multiples of 4 and 2. Multiples of 4, got 4, 8, 12, 16. Multiples of 2, 2, 4, 6, 8. I see that my lowest number, my least common multiple, is 4. So that means over here, in step 1, I need to rewrite these fractions as equivalent fractions with my LCM as my denominator. So that means I'm taking 3/4, and I need to turn it into a fraction that has 4 as a denominator. Well, 3/4 already has 4 as a denominator, so it's good to go. Now let's try that with 1/2. I need to turn 1/2 into an equivalent fraction that has 4 as a denominator. What did I do to this 2 to turn it into a 4? I multiplied it by 2, so I must do the same thing up top. 1 times 2 is 2. Now I've got 3/4 plus 2/4. Now that I have like fractions, I can simply add the numerators. 3 plus 2 is 5. I am counting fourths, 5/4. So my answer is 5/4. In this step, I need to think, does the answer need to be converted into a mixed number? Well, does 5/4 represent a quantity greater than 1 whole? It does. I can tell because my numerator 5 is larger than my denominator. Now, since every fraction is a division problem, I can rewrite this as 5 divided by 4. Now I know that 4 goes into 5 one time, and 1 times 4 is 4. When I subtract, I have 1 left over. So my answer is going to be 1 whole and 1/4. 1 and 1/4. 1 and 1/4. Now we need to see if we can simplify the fraction. Well, I know that when I have a numerator of 1, that is as simple as a fraction can get. There is no way I can divide 1 to make it a smaller number. So I know that I have my answer in simplest form. So the answer to 3/4 plus 1/2 is 1 and 1/4. That brings us to the end of today's lesson. Today's lesson was on adding unlike fractions. Go ahead and write this part down in the W section of your whisk. And our I can statement today:
I can use equivalent fractions to add and subtract unlike fractions.
Go ahead and press pause now if you need more time to write this on your whisk. For our summarizing question, I want you to explain in complete sentences how are equivalent fractions used when adding unlike fractions. Explain how we use equivalent fractions when we have unlike fractions we need to add. And finally, for the Q section of your whisk, here are 2 questions that I'd like you to attempt to solve. Remember that 4-step graphic organizer I used in the video, and I want to see if you can add these 2 fractions and write them in their simplest form. I look forward to seeing what you come up with in class tomorrow.